We're going to be solving several different types of problems, from the easy to the slightly more difficult to the sort of confusing, but actually not too hard. I would say that none of these problems in this lesson should give you that many troubles, except that this is true for these problems. You are not allowed to use a calculator. You are not allowed to use a calculator for these problems. There are going to be some tests in algebra where you will be allowed to use a calculator at my discretion. But most of the time when we have those tests, I'm going to say most of the tests you're not going to be able to use a calculator, and then there's one little calculator part. This test will allow you to use no calculator. You have to do all of these without a calculator. Are you going to have to do some long multiplication? Yes. Are you going to have to know how to multiply fractions? Yes. But that is all part of making sure that you're ready for algebra. All right, so let's begin. The first one is one that probably will require some long multiplication, 6 to the 4th. 6 to the 4th should be rewritten as 6 times 6 times 6 times 6. I just want to notify you this type of notation that I'm using here in algebra, where I just have a bunch of sixes in parentheses right next to each other. Very common notation for multiplying numbers together. So you'll see this all the time in algebra. Sometimes you'll see like letters, variables inside these as well. So it'll be like 6 times a. It's the same thing as writing 6a. Okay? Or if I have 6 in parentheses next to 6 in parentheses, that means 6 times 6. And that's what's going on here. 6 times 6 times 6 times 6 is pretty hard to figure out. But I can do 6 times 6 is 36. And if I use a little ingenuity at this point, I can do 36 times 6 as well. But then that last times 6 is going to be impossible for me to do in my head, so I'm going to have to do it on paper. But if let's see, 6 times 6 is 36 times 6. So 36 times 6 is the same as 30 times 6 plus 6 times 6. 30 times 6 is 180. 6 times 6 is 36. When I add those together, I get 216. Now, if you can't follow that, that's okay. You would just have to do 36 times 6 as a long multiplication problem on paper. For me, I can jump right ahead to this next step because I was able to figure out 36 times 6. All right, so 6 times 6 times 6 times 6 is the same as 216 times 6, but I'm not done evaluating yet. I actually need to evaluate what 216 times 6 is without a calculator. And the way to do that is long multiplication. 216 times 6. 6 times 6 is 36. I write the 3 up top. 6 times 1 is 6 plus 3 is 9. And then 6 times 2 is 12. When I put it all together, I have 1,296 as my answer. All right, letter B. 1.4 squared. Well, that's the same as 1.4 times 1.4. And unless you know what 14 squared is and have that memorized, you're probably going to have to do this one as a long multiplication, like this. 1.4 times 1.4. So the first thing I'm going to do is do 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. Bring down a 0 because I'm moving on to the next digit, okay? And then 1 times 4 is 4. 1 times 1 is 1. And then I'm going to go ahead and add straight down 6, 9, 1. And then lastly, I had 2 decimal places here total, so I have to move my decimal over 1, 2. But this makes sense to me as an answer because 14 squared is 196. And then if I just move my 2 decimal places over, I get 1.96. Letter C. How do you do 2/5 to the 3rd? Well, I'm going to tell you, you're not going to punch it into a calculator. But what you can do is just write it out in expanded multiplicative form, 2/5 times 2/5 times 2/5. And then I know when I'm multiplying fractions, I just multiply it across the top, then I multiply across the bottom, and then just leave what's on the top and what's on the bottom on the bottom. 2 times 2 times 2 is 8. 5 times 5 is 25. Times 5, well, I can figure that out by thinking about quarters. 25 times 5, well, that's going to be 125. 8 over 125 is my answer. I'm not going to change it to a decimal. And honestly, if this were an improper fraction, I'd just leave it as an improper fraction. All this is a perfectly proper fraction, so we're okay with the way that it looks. Letter D. 10 to a power is always really easy to deal with because all we need to do is collect all of the zeros and put them after a 1. How many zeros do we have here? 1, 2, 3, 4, 5, 6. So like 10 times 10 would be 100, but what is 100? It's just 1 followed by 2 zeros. If I multiply that by 10, I get 1,000. I'm adding a 0 for each 10, right? And if I add a 0 for each 10, I'm going to be left with a number that has a 1 followed by 6 zeros, or 1 million. 10 to the 6 is the same as 1 million. By the way, this ease of working with 10 is the reason why scientific notation works so well, which we're going to talk about later this year. All right, letter E should be pretty easy. W to the third, W to the fifth, W to the fourth, multiply together. Why, that's just going to be W to the 3 plus 5 plus 4, where 3 plus 5 plus 4 is my exponent. Or if I simplify that further, that's W to the 12th. There we go. Letter F is the same sort of thing, except I can't combine unlike bases. So I'm going to have Y to something, Z to something. Y to the 6 plus 5, Z to the 3 plus 11 plus 2. That's going to give me Y to the 11th, Z to the 16th. And then this last problem is the one that's confusing. The problem is written in a confusing way. It makes sense. These are always good. This one, by the way, repeats on future assignments and on future tests, so get ready for it. But I'm just going to tell you that this problem is easy. It always is set up the same way. You just have to pay attention to the setup. So let's just read this. If a supercomputer has a top speed of 1 EFLOPS, that stands for exaflops, by the way, which is equal to 10 to the 9th GFLOPS, or gigaflops, and if 1 GFLOPS is 10 to the 9th flops. So flops, by the way, is just a way of measuring computer speed. Okay, and these are real values that exist in the real world. What is a computer speed in flops? All right, here's what you need to remember about this one. First of all, don't worry about the confusing language of this. You don't have to know what flops are to make sense of this. And also don't worry about the confusing setup of the way this word problem is written. All you need to do, you need to remember that anytime this problem comes up, you are just multiplying the 2 numbers or the 3 numbers that are in the problem. In this case, it's 10 to the 9th times 10 to the 9th. That's going to convert exaflops first to gigaflops by multiplying by 10 to the 9th, and then gigaflops to flops multiplied by 10 to the 9th again. So if I set it up this way, does this look like something you can solve? Why, yes. And all you need to write for the answer for this one is 10 to the 18th. You don't even actually have to write it out as 1 followed by 18 zeros. You could. We learned in letter D that all you need to do to evaluate 10 to the 18th would be to write a 1 and then 18 zeros afterward. But for this one, I would accept 10 to the 18th. And for any time in the future you see this problem, I will accept it in its exponential notation as well. All right, that's how you solve these problems. You should be able to solve the ones in the actual lesson now. Make sure you get started at lesson 3, 1 through 30.